Hello, Jeremy. You can share your screen. Okay. Jeremy is going to do presentation about group 17. Jeremy and Jason.
Jason will go first, teacher.
So do we directly start, teacher?
Yes.
Okay, Jared, you can start the presentation.
You can start, Jeremy.
Can you guys not see the screen share, teacher?
I can see the screen share. If I can see, then others able to see also.
Okay. Hold on, teacher, I know the problem. There you go.
Okay, so I'm going to start the presentation. Good morning, everyone. Today we're going to be presenting about group 17. Jared, can you move to the next slide? Okay, so to make sure that everyone is on the same page here, the presentation is going to cover the group that is where the arrow is pointing right there on the screen. The group where fluorine is present and everything that is going to be under fluorine. Okay, next year. So group 17 is also called the halogens. The element ions has a charge of -1 or a valency electron of 7. The element has a force called the van der Waals force between the molecules. Next. During the halogen's melting point, the van der Waals force is partially overcame, and during the boiling point, it is almost fully overcame, turning the molecules into a solid or liquid respectively. Next year. Another characteristics of the boiling point and melting points are that they increase as we go down the group. This is because the increasing size of the molecules creating a larger intermolecular force, making it harder to boil and melt. Next. Now about group 17's color. So group 17's color depends on the absorption of color of the radiation that is close to the ultraviolet radiation that is in the spectrum of it. So depending on the position of the spectrum, the color shown and absorbed may differ, as you can see from the points that is written down on the PowerPoint. So also another thing about iodine is that it can be used to find if a solution is polar or non-polar. So when the solution is turned into gas, if the solution is non-polar, the gas of the solution will not change its color. While if the solution is polar, the gas will turn brown. Next year. So this presentation will also feature some reactions in group 17 that we are going to explain further. So I'm going to explain 3 of them and I'm going to leave the last one to Jeremy. Okay, next. So first up, it's a displacement reaction. This is the process of more reactive elements replacing the less reactive elements in a compound. So the reactiveness goes like this in the group 17, like chlorine, bromine, and iodine. So as most of you can tell, this means that the reactiveness decreases as we go down the group. Okay, next year. So next are the reactions of hydrogens with the halogens. So here, the table lists the reactions where the halogens are reacted with hydrogen. As you can see, the reaction becomes less vigorous when you go down the group. This is because the HX bond decreases down the group, making the reaction overall less exothermic. Next year. Now, this slide shows the test between each hydrogen halides when added with heat. The decomposition of hydrogen halide become more effective down the group. Similarly, this is because of the HX bonds playing a role in the different thermal stability. Because the HX bonds decrease as we go down the group, it is easier to decompose the molecules as we go down the group too. So now Jeremy is going to continue the presentation.
So this is chlorine reactions. Right now we're looking at chlorine in dilute and cold sodium hydroxide. This is when chlorine reacts with sodium hydroxide. If we look at the oxidation numbers, basically chlorine needs an oxidation of +1 to balance the equation because we have ClO and because we have ClO, we need to balance it out. And this is chlorine in hotter and more concentrated sodium hydroxide. Similarly, like earlier, it needs -1 and -6 to balance the equation. So this is testing for halide ions using silver nitrate. And basically, halide ions can be tested for using silver nitrate. They're dissolved in nitric acid, and then silver nitrate is added, and they're combined with ammonia to distinguish the type of halide ion. Oh yeah. And then they're combined with an ammonia solution so that you can distinguish the type of halide ion that is present. So over here we have the colors. Basically, if it's chlorine, then the precipitate from the reaction will be white. For iodine, it will be yellow, so you can distinguish between colors. And this is the reactions for sulfuric acid. This is one of them, preparation for hydrogen chloride, the formula is on screen. And basically, chlorine, iodine, and bromine have reactions with concentrated sulfuric acid to make different types of gases. Disproportionation is the oxidation or reduction of chlorine when it reacts with any kind of alkali. This is the different examples in different temperature. And basically in each of these reactions, there are cases for both oxidation and reduction, just at different stages. So if you break down these equations, there are parts, like on the right, you can see there are parts with reduction and oxidation. And chlorine is actually a very useful element. It's there's the formula for the manufacture of chlorine and in the purification of water. Chlorine is actually very useful in purification of water, but it also has other uses like in bleaches, disinfectants, refrigerators, and the whitening of paper. And then that's it from us. Thank you.
Okay. Thank you, Jeremy and Jason, for the presentation about group 17. I already explained and Jason and also Jeremy also do presentation regarding this group 17. Okay, I'm going to have just a bit of the review for this group 17 because we still have some time. Let me share. Okay. So on Wednesday, we are going to have the test as I told you. So in this one, I hope everyone can see screen that I am sharing. In this number, write the equations to show the action of heat on the following solid nitrates. State symbols are not required. So in this one, lithium nitrate. Lithium is a reactive compound, but comparing the reactivity, lithium is sodium is much more reactive than lithium. Okay, but the behavior of decomposition, it is the same, LiO, because it is in group 1 plus NO2 plus oxygen. This equation is not yet balanced, but the reaction is already complete. Okay, so I need help from Erica. Erica, can you help to add coefficient in front of the each chemical, each formula? What is the coefficient of this one? I give the blank
2.
for you to add the coefficients.
The first one is 2.
2. Okay. Next, lithium oxide.
1.
Lithium oxide is 1. Okay. Then nitrogen dioxide. What is the coefficient of nitrogen dioxide?
2. 2 NO2.
2 NO2. Yes. And then the last one,
1.
it is
1.
1. Okay. Let's see. The oxygen 2, 4, 5. In here 6. The oxygen is 6. Nitrogen is 2. Lithium is 2. Oxygen on the left hand side 6. This is, oh sorry, this is 4, 6, 7. 7 oxygen. On the right hand side there are 7 oxygen. On the left hand side there are 6 oxygen. Okay, so in this one, instead of 2, this one I would like to change the coefficient. So this one, lithium is 2, okay, because the oxygen is not balanced. So increase the number 2, lithium becomes 4, nitrogen becomes 4. In here, the oxygen 12, oxygen, this is 8, Yes, now this is balanced. Okay, and then for calcium, cesium nitrate, CsNO3 decomposes become cesium oxide, plus nitrogen dioxide and plus oxygen gas. And this one is making supposed to be like this, but cesium is very reactive. Cesium, it is down in the periodic table. Let me see. In the group 1, okay, so we have to refer to the data booklet. Cesium is very down, lithium is up, so it means this becomes very reactive. If very reactive, then cesium will not form nitrogen dioxide and oxygen, but will not form nitrogen dioxide, but this Cs nitrogen cesium nitrate and then plus oxygen gas. It is like the potassium. This question similarly appear when we studied in IGCSE. So in this equation, we write 2 over here and then 2 over here. The oxygen becomes 6, balanced. Solubilities of the sulfates and hydroxides of the calcium and barium are shown below. Use the information in the table to answer the questions that follow. Okay, solubility, calcium sulfate and barium sulfate. Calcium sulfate is slightly soluble, while the barium sulfate is completely insoluble. Okay, and then for in terms of the substance, there is another substance which is comparing between calcium hydroxide and calcium and barium hydroxide. Okay, so calcium hydroxide is slightly soluble, while barium hydroxide is very soluble. Both calcium and barium metals react with water to give the metal hydroxide and hydrogen gas. What difference would you expect to see after calcium metal and barium metal have reacted with water? So this observation is based on the visibility. We can see this one, barium, this one, because calcium both give metal hydroxide and hydrogen gas, slightly soluble and soluble. So here barium will form a clear solution, while calcium will form cloudy solution because of slightly insoluble. because it is slightly insoluble. Okay, slightly soluble or slightly insoluble, slightly soluble. Okay, so it is not completely soluble, but it is partially. What is meaning by partially? Some fractions we see it can dissolve, some fractions cannot dissolve. Next, 2, the reaction between barium metal and excess sulfuric acid stops after a very short time. Explain this observation. When barium reacts, the surface reacts in barium, when it reacts with sulfuric acid, surface of Ba reacts, forming barium sulfate. Acid, sulfuric acid does not react with sulfates compound. Okay, so sulfuric acid does not react with sulfate compound. This is the reason why after some time barium does not continue reaction with barium with sulfuric acid, and then suggest the solubility of, put a cross in its box. Okay, a solubility of radium water of radium sulfate. Radium. Okay, so when with radium sulfate, it is becoming insoluble. Okay. Oh, sorry. It is insoluble, totally insoluble. Okay. Then next, write ionic equation for the reaction between calcium metal with hydrochloric acid. Include state symbol in your equation. So here is calcium Ca2 plus HCl, okay, Cl H plus becomes, this is calcium metal. Oh, sorry, calcium metal. This one solid, aqueous, becomes hydrogen gas plus Ca2 plus. This one aqueous. Okay, so based on the number of atoms left and right balanced, and also based on the charge also balanced. Next, state the flame color of barium. Okay, barium, it has color of green color. Green color, and then for strontium, it has the color of red. When barium is burned in excess oxygen, a compound containing 81.1 barium and 18.9 oxygen is formed. So we make the ratio barium against oxygen ratio. So barium is 81.1, oh sorry, 81.1 ratio 18.9. Then for the AR, barium, we see on the periodic table 137. 137.3. Oxygen here is 16. So the moles 81 divide, so 81 divided by 137.3, 0.59. Okay, so 0.59, and then 18.9 divided by 16, which will produce 1.18, and then divide by 0.59. This is 1 divided by 0.59, 2. So the formula is BaO2. Write equation for the reaction of barium with water. Do not include any state symbols. So this one, barium plus H2O will become barium hydroxide and hydrogen gas. Plus hydrogen gas. When small piece of barium is added to water, the barium gets smaller and eventually disappear. State two observations you could make. So first observation, barium metal dissolves. Number 2, there is a heat change, heat forms, exothermic. And then the third, there is a bubbles of hydrogen gas. Okay, next, what would be the effect of adding piece of blue litmus paper and a piece of red litmus paper to aqueous product of reaction in 2? Red turns blue. Blue remains blue. Blue remains blue. There is no change with the blue color. Okay. So let me, before I continue again, completing this one, let me take attendance for today. Okay, grade 11. Angelica is here. Marvel is here. Then Adeline, Amelia, Clarence is here. Ins is here. Erika is here. Felicia is here. Okay, Clarence, Felicia is here. And then next, let me scroll down. Gede is here. Hansen is here. Hillary is not present. Okay. Jason is here. Jeremy is here. Jolin is here. Lupin is here. Then Kimi is here. Laura is here. Lee Chan Young is here. Louis is here. Maya is here. Michael is here. Michelle is here. Subasa is here. Okay. Subasa is here. Then Natalie. Natalie is here. Nikki, Nico is here. Owen here. Ratu. Ratu is here. Then yes, Raymond is here. Richie is here. Rich is here. Robbie is here. Then Samia, Samuel, Fania, Vincent. Vincent is here. Then last, we wish is here. Okay, so all present except for Hillary. Okay, so I think we will continue again tomorrow. Tomorrow is the last review for before the test on Wednesday. Okay, so good morning and thank you.
Thank you, teacher.
Okay.